Hello, dear students. So we are making the videos for online lectures. Initially for the mathematics calculus. So you know this in mathematics, different types of the mathematics, algebra, arithmetic, then trigonometry, geometry, statistics, logical mathematics, which is useful for the computers, and calculus. So calculus is the mathematics of engineering and science. Without calculus, development in engineering and science not possible at all. So to understand this calculus perfectly, you must be the solid and strong in the functions. So today we will study about the functions. So first of all, we will understand about the intervals. So in mathematics, different types of the intervals. First type, open interval. So open interval. So value lies in the domain of the AB. So now this is written as round bracket AB. So open interval, round bracket AB. So if we write round bracket AB, that is the open interval, that is A and B are not included. Here A is equal to lower limit and B equal to upper limit. So lower limit and upper limit are not included, that is excluded, then that interval is open interval. Second interval is closed interval. So A less than or equal to X, less than or equal to B, that is this written as square bracket AB. So square bracket means lower limit and upper limit included. So here in this interval, suppose A is lower limit, B is upper limit. So this complete set including A and B also. Here interval takes the values here. So these and these values are not included. Third type of the interval, semi-open and semi-closed interval. So semi-open and semi-closed interval, that is A less than X, less than or equal to B. That is, we will write A open and B is closed. So this is semi-open, semi-closed interval. So here lower limit value is not included, but upper limit is included. It takes the values like this. Fourth type of the interval, semi-closed and semi-open interval. Now semi-closed, semi-open interval, so A less than or equal to X less than B, that is square bracket A and round bracket B. So here, so lower limit A is included but upper limit B is not included. So this takes the value like this. So these are the different types of the intervals. Now next we will understand about the constants and variables. So constants means value is constant, value is fixed, that is the constant value. So this in mathematics and in engineering there is one consideration, that is the standardization. So in maths also we want to use the standard. So what are the standard alphabets used for the constants? So for constants use alphabets A, B, C, C, D, E, F, G that are used for the function H, I, J, K, L, M, N, P, Q, R, like this, etc. So these are the alphabets used to indicate the constants. Now variables, value varies. That is, with that variable takes different values in its domain. So variables are denoted by alphabets so X, Y, Z are also variable. R, S, T, U, V, W, etc. So mostly these alphabets we are using to indicate the variables. Now next we'll understand the concept of this function. So first of all, we'll see what is the definition of this function. So fundamental, very simple definition of the function. Definition. So we have studied the set theory. Then you have studied the relations between these two sets. So after that, this concept of the function arises. So to understand this function, you revise the set theory relations, and then we'll go to the functions. So what is the definition of the function? So it is the relation between two non-empty sets A and B such that A related to the B is bijective relation. Bijective relation. So it is the relation between two non-empty sets A and B such that A related to B is bijective relation, and each and every element of set A is related uniquely to element of set B. Set B. So very important here is the function is the relation between two sets A and B. That relation is the bijective relation, and this is very important. Each and every element and uniquely. So each and every element of set A is uniquely related to the element of set B. Then and only then that relation is the function. So every relation is not function. Each and every element of A set A is related uniquely to the element of set B. Then and only then that relation becomes the function. That is, we will write the equation for that relation. Now here A is domain of function and B set is codomain of function. Codomain of function. P is the codomain of the function. Now, depending upon the relation, types of the functions. Actually, these functions are denoted as f of x, g of x, h of x, or maybe small f of x, small g of x, small h of x, again phi of x, psi of x, rho x, etc. Now, types of functions. Depending on relations. So, which type of the relation is there? On that type of the relation, how the functions are classified. So, basically, functions are classified into two ways. One is onto function, and other is into function. So, onto function means what? Actually, notice in function, each and every element of set A is related uniquely to the element of set B. Means there is no any unrelated elements in set A, but in B, some elements may not be related, or maybe all the related. So onto function, all elements of B are related. So, if we consider A and B, suppose two sets. Suppose A takes the elements A, B, C, D, etc. B takes the element 1, 2, 3, 4, etc. Now here, suppose A is related to 1, B is related to 3, 4. So here, each and every element of set is uniquely related to the element of set B. And here, there is only one element is related to each element. So this function is onto function, and in that again, this is one onto function. So here, two types we are getting. So first type is one onto function. Now second type, many one onto function. So from this sketch, you will understood this. So this is the function here. So A set and B set. So A takes the value, suppose A, B, C, 1, 2, 3, etc. like this, D. Now suppose A is related to the 1, B is related to the 2, C is again related to the 1, and D is related to the 3. So here, each and every element of A is related, but to the element of B, that is 1, more than one element of A are related, A and D related there. So if any one element of B is related to more than one element, maybe 2 or 3, etc., one or maybe more than one elements are related, more than one element in A, then that function is many one onto function. So for onto function, all the elements are related, no any element is remaining here. So this is the many one onto function. Similarly, in into function, there are two types we are getting. So here, some elements of set A, set B are unrelated. Here also two types will get one into function and other type is many 1 into function. Now 1 into function. So shapes denoted by the elliptical shapes or maybe circle, and universal shape by the square or rectangle. So A and B will consider two shapes. So when it is the function, suppose A takes the values A, B, C. B takes the values 1, 2, 3, 4, 5, etc. So suppose A related to the 1, B related to the 3, and C related to the 4. So here 2 and 5 are unrelated. So this is the function because all the elements of CET are uniquely related. A मधनं एकावेळेस एकच लाईन बाहेर पडली पाहिजे. B मध्ये एका पडल्या एकापेक्षा जास्त लाईन्स आल्या तरी चालतं. So this is 1 into function because 2 and 5 elements are unrelated. So many 1 into function. So A and B will consider two sets. Suppose A takes the A, B, C. Here 1, 2, 3, 4, 5, etc. Suppose A related to the 1, B related to the 2, and C again related to the 1. So here in set B, 1 is related to the A and C more than 2 elements of the A. So that's why this is many 1 function. And here 3, 4, 5 elements are unrelated. That's why this is many 1 into function. So these are the different types of the function depending upon the type of the relations following that function. Now next we will study mathematical functions. So that is very important in calculations, analysis, to solve the examples in calculus. So mathematical functions. So in mathematics, basically 6 functions are there: L, I, A, T, E, H. So these ones are the functions in the mathematics. So whatever the mathematics you are studying, you will get the total 6 functions are there. Now first function is L, means logarithmic function. So this logarithmic function, you have studied this log in A-level standard or 10 standard. So that concept you keep in the mind long life until you are studying this mathematics, engineering, etc. So these rules, definitions, etc. must be with you. So what is the definition of this function? So first of all, we understood the definition. So definition of log is if a raised to x, a raised to x is the exponential function, is m, then x is equal to, we write log m base a. M greater than 0, not greater than 0, and a not equal to 1. So the base, this is a is the base, and this m is the radical of that logarithmic function. So a is not equal to 1, other than 1 value we will take, and m is always greater than 0. So this is the fundamental definition of the log. Now to analyze the logarithms, what are the rules are there? Some rules are there. For every function there are the rules for the calculations. So what are the rules in the logarithm? So first rule we get log AB. So log AB means if there is the product, so we can write log A plus log B. Log A upon B, division असेल तर subtraction, log A minus log B. Third rule in logarithm, log A raised to m, we can write m log A. Fourth rule, log A raised to m, and suppose base B raised to n. So So that is equal to, we can write m upon n log a base b. Then log a base b, and if you want to change the base, we'll write log a divided by log b. Log a base b, we can write 1 upon log b base a. A raised to log x base a. Here log and anti-log, so this value is x. E base is here and the same value is x. Log x cancels, log and anti-log there. Then some standard values you want to keep in the mind. So standard values, these are the rules which are used in the logarithm. Standard values. So what are the standard values? So log 1, what will be the base? Suppose here base is a equal to 0 and log a base a is equal to 1. Log 0 is not defined, very large value infinity. Similarly, log infinity, that is also the infinity. Now next, we'll study what are the types of logarithm. That also you must know. Types of logarithm. So in logarithm, 3 types we can consider. One is the common logarithm, natural logarithm, and general logarithm. So common logarithm base is equal to 10. Natural logarithm base of log is always e. The value of e is constant 2.71828. General logarithm base other than 10 and e. Again, you know this base not equal to 1. Now this common logarithm is used in algebra. Actually this logarithm chapter is from the algebra mathematics. So when we are solving the examples of logarithm chapter, when base is not stated, you take the base e. Natural logarithm, this is used in the calculus. In calculus, base of log is e and that natural logarithm. So in calculus, that is when log function is coming in, limit, derivative, integration, etc. So base is not stated, you consider or you assign that base is e. And general logarithm, base is always stated. So here in algebra, so log x base, log x is written, we will consider this as a log x base 10. In calculus, if log is written like this, we will consider this log as a log x base e. And in general logarithm, base is always stated there. So log x base 2 like this. So in algebra, that is when we are studying the chapter logarithm, the base is not stated, then base is 10. When we are studying the calculus, that we are studying log function is coming in, limits, derivative, integration, etc. When base of log is not written, you consider the base e. And when base is other than 10 and e, that is always indicated like this log x base 2. So this is the basic concept of the logarithm. Now here by using log tables, how will you take the logs? So that you are studying for the practicals, etc. So that will not explain you. We are prepared, main intensity of your preparation must be the strong for calculus.